Hello, geometry. One last time here with remote learning. We are going to be graphing linear equations in which it's not in its standard template format. It's not in slope-intercept form. So I'm going to show you guys how to get that, and that'll be it for semester 2020, spring 2020. So let's get to it. So number one, x minus 5y equals 10. You guys have pretty much seen how to do this already. I'm just reviewing some concepts for you. Remember, the template is y equals mx plus b. M is the rise over run. B is the starting point or the place where it crosses the y-axis. So when we see this, we're just trying to get y by itself, preferably on the left-hand side. So I'm going to subtract 1x. I put a 1 as a coefficient for the x from both sides. That gives me negative 5y is equal to negative 1x plus 10. Just a quick thing. I'm putting the x term first because, well, the x term is first in the template, y equals mx plus b. Divide by negative 5. Make sure you guys aren't dropping your negatives. That tends to be a consistent error I see among students. And that leaves us with y equals, a negative divided by a negative is a positive 1/5 x. A positive divided by a negative is a negative 2. So, y equals 1/5 x minus 2. This means we're starting 2 units below the x-axis because of the negative. So go down 2, plot a point, all right? Here's my y-axis, here's my x-axis. I am now going to travel up 1 unit, right 1, 2, 3, 4, 5 units because my rise over run is 1/5. I can also go down 1, left 1, 2, 3, 4, 5 to plot my third point. And it's probably a good idea if you guys would tell me what the slope is and the starting point, just to communicate with me that you guys understand what the starting point and the slope is. So make sure you connect the dots at the end. And there's our first line. Let's check out number 2. So you got 3y plus x equals 13. I'm going to put a 1 in front of the x so that there's no confusion at all later on down the line. Remember, we want y by itself, preferably on the left-hand side, so I'm going to subtract the 1x from both sides. Then you've got negative 1x plus 13. Divide everybody by 3. And you get y is equal to negative 1/3 x plus, now I'm going to figure out what the mixed number on this is because this is going to be the number that tells us where to start on the y-axis. So 3, 6, 9, 12, so that's a whole number of 4, plus 1 left over, it's going to be 4 and 1/3. So the slope-intercept form is y equals negative 1/3 x plus 4 and 1/3. That means that your starting point B is going to be 4 and 1/3 units above the origin on the y-axis. So you're going to go up 1, 2, 3, 4, and then 1/3 of a block. Which is about right there. And then from there, okay, so this is where students sometimes get really confused about the negative. They're not quite sure if the negative goes with the top, the bottom, or both. In order to get a negative number with division, you got to have a negative divided by a positive or a positive divided by a negative, not both of them being negative. So it's a negative 1 over a positive 3 or a positive 1 over negative 3. So you're never going to go down and left. It's always going to be up and left or down and right. So you go down 1, right 1, 2, 3. Plot another point, down 1, right 1, 2, 3. Or go up 1, left 1, 2, 3. Up 1, left 1, 2, 3. was the y-axis. Here's my x-axis. Make sure you guys are connecting the dots at the end. If it says graph the linear equation and you just plot a bunch of points, you're really misrepresenting the equation. The equation is a line, not just a series of points that are 3 units away from each other. So, all right, we're rolling through this thing. Number 3. I got 5x equals 15y, but my first move is actually going to be using the symmetric property to rewrite it so that y is instantly on the left. It just kind of makes sense to me. English language readers read left to right. Y equals mx plus b is written left to right. So let's just make y on the left-hand side every time. In this case, we're trying to get y by itself. There's nothing more to do except divide by 15. And 5 divided by 15 is going to simplify to 1/3 if you divide the top by 5 and the bottom by 5. Now, what happens if there's no extra? It seems like there should be like a plus 4 1/3 or a minus 2. Something should be there. Well, there's numerically nothing. So the number that represents nothing is 0. So you can just tag along or tag on a 0 there. Okay. So hopefully that makes sense. That b now starts 0 units from the origin, so it's actually right smack dab on the origin. Then you're going to go up 1, right 3 based on our 1/3 slope. You're going to go up 1, right 1, 2, 3, up 1, right 1, 2, 3. Okay? Or you could go down 1, left 3. Down 1, left 1, 2, 3. Connect the dots and you're done. So those are your basic examples. Let's try some that are a little bit more rigorous. All right, so I've got decimals. And I'm actually going to change this second example. I'll explain myself later. But let's just focus on number 4 for a moment. 1.8x equals 5 minus 3y. I'm again going to rewrite the left-hand side of the equation on the right-hand side and vice versa. I'm going to switch these two using the symmetric property. So I'm going to say 5 minus 3y is going to be my left-hand side, and 1.8x is going to be my right-hand side. Now I want to get y by itself because that's our template for writing an equation. So I'm going to subtract the 5 here. Remember, I can't take 1.8 minus 5 because it's multiplied by the x. Now divide by negative 3. So 1.8 divided by negative 3. Well, if you multiply the top and bottom of this fraction by 10, you would get 18 over negative 30. It's kind of like the whole move the decimal over trick in order to get rid of the decimal. And then the top and bottom are both divisible by 6. So 18 divided by 6 is 3. Negative 30 divided by 6 is 5. So you got negative 3/5 as your x term. Okay? Our slope is negative 3/5. Now negative 5 over negative 3, remember, we want to represent this as a mixed number or maybe even a decimal because it represents the b value, the starting point on the y-axis. So I'm just going to say a negative over a negative is a positive. 3 goes into 5 one whole time with 2 leftovers. So it's 1 2/3. That's going to be our starting point. All right, so this was our m value. and this was our b value. So you'd start 1 2/3 units above the x-axis at the origin, and then you're going to go down 1, 2, 3, right 1, 2, 3, 4, 5, or up 1, 2, 3, and left 1, 2, 3, 4, 5. Okay, now I had another decimal example on the notes, but I figured it would be a lot better use of our time if we talked about vertical and horizontal lines. Those lines sometimes show up later on. You might not have any on the assignment, but I thought I'd expose you to it just for this assignment itself. So when you see x equals 4, that's actually a special case. It doesn't have a legitimate rise over run value. It's a vertical line, totally. So it's kind of like x equals 4. Well, here's my x-axis. That means every time you move left or right, you are talking about an x unit move. Well, this says x equals 4. 1, 2, 3, 4. This would be a point in which x is equal to 4. It'd be 4, 0. Here's another point. X is 4 if it's the point 4, 2. Here's another value in which the x value is 4. It's go over 4, up 7. So a line that is vertical, that goes through all the x equals 4 coordinates, would be written like that. Similarly, horizontal lines are written like this, where the y value is always some kind of constant value. So it'd be like, here's the point x equals 0, y equals -1. It'd be that point right there. Here's another one, -5, -2. I'm sorry, -5, -1. The y value is again -1. 3, -1, y value also equals -1. So this would be the line y equals -1. Here's x equals 4. There's y equals -1. All right, I think I'm going to stop the video right there. We don't really have any examples with a bunch of fractions on it, so I'll let you guys get to the homework. Again, please read the instructions carefully. I gave you half the answers. I believe I gave you the evens. Your job is to do the odds, okay?